He is the Senior Director of Design Engineering at AMD, leading the CPO design team in India. He has nearly 24 years of experience in various aspects of implementation of microprocessors and complex ASICs. He has worked at Sun Microsoft Systems, MIPS, Broadcom in USA, and Qualcomm in India. Umesh received his bachelor's degree in electrical engineering from College of Engineering, Trivandrum, and master's degree from Texas A&M Cornell University. He has received 3 patents for innovations and implementation and has spoken at numerous conferences. So with a big round of applause, let's welcome Umesh Nair.
Let's see how many of you have been listening attentively. Any guesses on what this number is? 1.15 trillion. Yeah, I can't hear it. Okay, I think some of you probably got it right. So these were the number of semiconductor units sold in 2021. Of course, 2022 was down a little bit because of the China and the supply shortage. But these many ICs, right? A lot of us today have mobile phones, probably 3 or 4 chips in there. So even in this room, there are so many semiconductor devices. That's just good to keep in mind. But then the next question among all the leaders and people running businesses, so what, right? How does it translate to money? So this is a slide from McKinsey, which is one of the world's leading business consultants. And their study shows, and this was a number that Rajiv, I think, mentioned in his talk, but I think slides are a little easier to remember. So you see that, I hope you can still hear me. No? Okay, let's see here. All right. So you can see that from today to 2030, the semiconductor revenue is going to double. And it's going to be a 1 trillion business in 2030. Any guesses on why, what is driving this? And I think a few of the speakers mentioned this. So any guesses? What are the key drivers? Automation, I hear, not quite. But before I go on, so the 3 areas, if you look at this slide, there's, automotive, data storage, compute, and wireless industries. And the reason for these are the mega trends are really, remote working, COVID. You can imagine every family had 1 laptop, probably, or maybe 2. And then students and kids are working from schools, so then you need another laptop. So that expansion during COVID was really 2 to 3 times. So that's one area, right? The second is growth of AI. And how has this triggered growth, right? So today, okay, there's no AI for this. Product one of you will design in the future. But anyway, so growth of AI is, so today if you look at YouTube, right? You see all these searches, everything is tuned according to what you look at. That is also some machine learning in the background. And machine learning really needs a lot of compute. So you need more chips, more processing in the background for those YouTube servers as an example. So that has again led to a lot of growth. Third is electric vehicles and automated auto driving, right? That is all controlled by processors and chips and again a lot of compute. The fourth one, of course, with the bandwidth and 5G improving. I was talking to one of the interns who joined my team, and they came and asked me, don't you have videos? I'm not used to looking at slides and books. I learn from videos and animation. So our CAT team has actually gone and done a lot of training in video. But video, again, is a lot of processing power, again needs chips. IoT, someone talked about, right? The Alexas, the Googles, the burglar alarms, right? All of that is again compute. But which is the biggest one? There's another big factor which is really helping growth in other parts of the world, especially places like India and any guesses? It's a global economic thing which is helping drive semiconductors globally. It's because of China. Thank you, China, right? So China and US have this issue. So what's happening is now you need more semiconductors in all different parts of the world, which is a boon in some ways. Okay, so now, technology, for many of us who have worked, it's already 25 years, we are at 3 nanometer, maybe 2. Does this support the growth, right? What after silicon? I mean, 1 nanometer is pretty small. And there is, and most of the companies have shown, and there is a process roadmap. This shows the process technology over the next 10 years, right? So the first one shows dimension scaling, that you can go to angstroms. The second one shows that, I think somebody talked about the founder of FinFETs. That's at the beginning here, and then you move to gallium arsenide and so forth. And then the third one is, even within the processing, you can do different types of interconnect. So nothing to worry. There is a roadmap, and the fabs are all working on this. A lot of research for some of those who ask the questions on research. Another thing that we need to be aware that is really driving a lot of this growth is you can't make these big chips anymore. And with the technology, the cost is becoming very high. So packaging technology actually allows you to put multiple chips together and also reusing parts. So you can have your memory block in one chip, use it for 5 generations, just do the logic and the IP that you're innovating on as a company. And package technology, this is pretty recent. I mean, it's always been there, but this has again another driver which is taken off. And I was glad to hear, I think one of the speakers mentioned that there's a lot of package stuff in India as well. All right, any questions on any of this? Okay. All right, and just a touch, and again, I think this was a little bit covered, but just some data, and this is all public material that I was just looking up, and there are 2,000 chips designed in India, and each chip, can vary from 10 to 200 people, right? So I think that was the number the previous speaker showed, around 20,000 engineers, and a lot of new stuff, right? Indian semiconductor market is expected to grow 3 to 4x in the next 5 years. There is, I think, this Gujarat, I think the second one, I think Rajiv mentioned, is already done. I think this is probably from a news article a year old. I think Tata Group is investing, and one of the panel speakers said that announcement should become public in a month. And then the government initiatives, which I was very happy to hear some of you on the panel be aware of all these PLI, and I think that is a great question. So a lot is happening in India, right? So all of you are at the right time, at the right place, which is, I think, very, very important in our careers. Okay, so now that we know the semiconductor industry in general and what's happening in India, I will cover a little bit about AMD, what AMD does, and what our teams in AMD India do. 25,000 member company. It used to be about 13,000 a few years back. So a lot of growth. I think we can shift to at least, okay. We'll keep this nice packaging picture. Because AMD was the pioneer of packaging technology. So AMD is one of the few companies which have focuses on high performance computing, right? And high performance computing is everywhere, in cloud, in data centers primarily. And with the Xilinx acquisition, AMD's expertise is in CPUs, GPUs, one of the few companies which have a significant market share in CPUs and GPUs. Many have tried but failed. We also make products for customers like game consoles and things, so AMD is there as well. And a lot of semi-custom business, and then all FPGAs from Xilinx, and a big player in the embedded, and we also had a recent acquisition called Pensando in the networking space. Okay, in AMD India, we do actually 25% of AMD's workforce, 6,000 folks of the 25,000 are in India. And AMD India is involved in every single product that AMD makes. And you can see some of the interviews. I think one of our, Lisa Su was here, the CEO was here a couple of months ago, and it was a great experience. And India is growing, AMD is hiring a lot. Slightly slower now, but we do have, for those faculty and colleges, we do have a very good university relations program where students come in for a 6-month internship, which is probably very relevant. And you can reach out to our university relations. And we do hire a lot of freshers in general. So in terms of products, we do, SoCs, CPU, GPU, everything that I mentioned, AMD India is part of. And in terms of domain, also we have complete coverage from RTL design to design verification to physical design to silicon validation and emulation and all the things that we covered about it. That's okay. All right, any questions on AMD at this point? I can get into as much detail as needed without the slides, but okay. I'll just have one more slide, which I'll go back. So this is a slide that I put together specifically for this audience. Oh, is it? It's not coming. Something else is put together for this audience. We have hundreds of job descriptions for freshers, different ways, and each team we're having a lot of technical difficulties here. Okay. So one thing I put together is, what do we look for in freshers or engineers, and what is the message that, with my experience, I can tell all of you, right? So one thing very important for a VLSI engineer is a good understanding of fundamentals. Easier said than done, right? Because there is so much to learn. There are equations, textbooks, but really for success, you need to have a very clear thought process, right? And I believe clarity of thought, whatever the problem is, you don't understand in detail, break it down into a way that you understand and have that clarity of thought. It has to be crystal clear in your mind. And I think that is a fundamental quality, not only for a good engineer, I think for success in any career. Second, with so many technology challenges, it is very complex, right? Be it design verification, be it physical design, the work is really complex. And things don't work as expected. right? We always have problems with tool vendors. But everything does not work as expected. So you need to be very creative and innovate and have that critical thinking skill. And third, like in the panel and other speakers, this field is vast, right? So you can learn different things and have a broad knowledge, or you can go really deep, like you can become an expert in one particular area there are people who have worked on one thing for 25 years, right? But that curiosity and hunger for knowledge is very, very important. I think if all of you have seen Steve Jobs' message, right? Stay hungry, stay foolish. I think all of you should listen to that video and that last sentence. I think that is particularly important in semiconductors because you can get lost. And the next two, I think as Monty mentioned, I think the soft skills are very, very important. Because you need to work with others, because you cannot go build a chip by yourself. I mean, there are maybe a few people in the world who have done that, but you need to work with others. So that teamwork and the ability to work is very important. And last but not the least, good communication, because even if you have the best idea in the world, you need to be able to express it to others. So that's all I had. Any questions is welcome. If not, I wish you all the best, and hopefully we'll see some of you at AMD in the future.